This is page 3 of the 1-2 notes where we are discussing quantitative data. And I want to talk about what graphs are appropriate for quantitative data. The first one is a dot plot. It's super easy to make. You can see an example of one right here. Now, I said here you can mark a dot or X's to represent each data value. And basically what you're doing is you're stacking whatever symbol you use so that when you're done, it actually looks like a form of a bar chart. Just make sure when you draw the symbols that they are equally spaced vertically so that the heights of the columns can be compared. You don't want to make super tiny symbols on one column and large symbols on another column so that one looks more exaggerated than the other. The data set below shows the time in minutes it takes for a fast food restaurant to fulfill 30 orders over a lunch hour on a single day. So this dot plot right here represents the number of minutes to fill the 30 lunch orders. And I mentioned here, there are a couple of statistical software packages that you can use if you had them. One of them is Minitab. That's what we use at school. And this dot plot was created in Minitab. Excel does not create dot plots. So what I want you to look at here is I made this for you, and you can see the scale that if this is 2.4 and this is 3, this must be 2.6 and 2.8. So we're going by 2/10 for every single mark along this axis. And literally that's all this is. So the fact that there are 1, 2, 3, 4 dots right here, that would be 2.2. You can see there's 1 and 2 and 3 and 4 2.2s right there in your data. And that's all you're doing is you're stacking the symbols. Now, the nice thing about a dot plot, besides the fact that it's easy, is if you keep the scales the same, you can compare multiple dot plots. And then you might be asked to compare distributions. Now, I'm going to make a caution right here. If it says compare, do not just list characteristics of SOCs. Remember, that stands for spread, outliers, center, and shape, not necessarily in that order, but don't just talk about the characteristics of each. If it says compare, you have to do exactly that. You have to compare. So I said the dot plots from the restaurant mentioned above and a second franchise of the same restaurant are displayed below. So we have restaurant A, and now we have a new one, restaurant B. Which sentences would be best to use if you are asked to compare the distributions? So to save us a little bit of time here, instead of asking you to come up with the sentences, I've given you some options, and we're just going to pick the ones that might be good. So the first one says the distribution for restaurant A is centered at about 2.8 minutes. So 2.8 would be right about here. The distribution for restaurant B is centered at about 3.4 minutes. Those are both true statements. If I look at this again, I might actually say that this one is more like 2.7, 2.6 or 7, but assuming the 2.8 is correct, that's a true statement, but you're not comparing. You just said this one's centered at 2.8, this one's at 3.4. So even though it's a true statement, I probably wouldn't use that one. The amount of time it takes to fulfill an order at restaurant A spans from as little as 2.2 minutes to as long as 6 minutes. Again, true statement, but you haven't compared anything. The range of time it takes to fulfill orders at restaurant A, 3.8 minutes, is higher than the range of time it takes to fulfill orders at restaurant B, 3.4 minutes. Now that's a comparison because you're saying it's higher than. So that one I'd use. I'm going to give that a yes. At restaurant A, nearly 2/3 of the orders took less than 3 minutes, unlike restaurant B, where more than 2/3 of the orders took more than 3 minutes. Now, I'm not going to confirm the 2/3, but assuming they're both correct, again, even if this was true, you didn't compare. You just said what was true at A and what was true at B. You didn't compare anything, so I'm not going to choose that one. In general, restaurant A fulfills orders more quickly than restaurant B. All right, I like that because in general, restaurant A is down here where restaurant B is here. So that is a true statement and it was a comparison. We'll give that a yes. Restaurant A has a higher maximum at 6 than restaurant B, which is 5.6. There's another comparison because we have higher than. There were 2 orders at restaurant A that took 6 minutes, while the maximum number of minutes at restaurant B was only 5.6 minutes. True, but no comparison. The spread of the distribution for restaurant A is greater than the spread for restaurant B, but that's only because of the 2 unusually high values at 6 minutes. That is a true statement. It's a comparison. And what I also like about that one is it discusses the fact that the range is only as high as it is because of those unusual values. So in that statement, you've actually addressed 2 characteristics of the socks. You've addressed the spread and the unusual values. The distribution for restaurant B seems to be somewhat symmetrical. Barely, but kind of. It's kind of bell-shaped, kind of unimodal. The distribution for restaurant A shows less symmetry and a little more right skew than restaurant B. All right, I like that. Less symmetry, more than, because this one, it seems to be mostly the data's over here and then it's kind of trickling off. This would be a slight right skew. So I like this one. We've talked about shape and we've compared in that description. So remember, if you're asked to compare, you can still focus on socks, but you have to use comparison words.